Hey everyone, welcome to part 46 of my Pokemon game series in Unity. So in the next few videos, we will look at how to save and load all the data in our game. So in this video, we'll start by saving some simple data like the player's position and some trainer data, and we'll look into saving more complex data in the next video. Special thanks to all my Patreons for making the series possible. By becoming a Patreon, you can support me in the making of the series and get access to some cool rewards like the complete project files of the series, which also contains some advanced features that are not covered here. So let's start the video. So to save the data of our game, we have to convert the data in our game objects and components into binary, and then we have to store that binary data into a file. So for this, I'm not going to create a complete saving system from scratch. Instead, I'm going to use a saving system that I usually use. So it can be downloaded from my GitHub page. I'll put a link to it in the description. So once you download and extract it, you can import it to your project by dragging the asset file to the assets folder. Okay, so I'm just going to select all and import. All right, so once it's imported, inside your scripts folder, you'll see a new folder called saving. And in here, we have 3 scripts. So I created this saving system when I was following this course from Game Dev TV. So I just want to give a huge shout out to them. And if you want to learn how to build this saving system from scratch, then you should check out this course. I'll put a link to it in the description. So let's get back to the video. So inside the saving folder, we have 3 scripts. So the saving system script is the actual saving system with functions to save and load data to a file. Savable entity script is used to mark a game object as savable. So if it's attached to a game object, then the saving system will know it's a savable object. And finally, iSavable is an interface that every component should implement if the component needs to save any data. All right. So first, let's look at how to use this system to save the position of the player. So I'll open my player prefab. And in order to mark the player as a savable object, we have to attach the savable entity script to it. Okay, so let me attach it. So here you can see that we have a field called unique ID. So this ID is used to uniquely identify this game object while saving and loading. So why is this ID null over here? It's because we have attached it to the prefab, right? This is not an actual object in the scene. So since only objects in the scene can be saved, the unique ID will be null if it's attached to a prefab. All right, so if we go back and drag the player prefab into the scene, now you can see that unique ID is no longer empty. It's actually populated with a unique string. But if you open the prefab, here you can see that it's still empty. So the thing is, while using the system, the player prefab should be there in the gameplay scene, right? Right now we are just loading it dynamically by using essential objects loader. But when we load like that, the player's unique ID will be empty. So in the gameplay scene, it's not necessary to load the essential objects like this. Since the gameplay scene is only loaded once, we can just directly put our essential objects in there. So let me just delete the essential objects loader and let me place the essential objects directly in the gameplay scene. So this can only be done with the gameplay scene since it's only loaded once. For all the other scenes, you should use the essential objects loader itself. So we don't need this player instance anymore since we have it inside the essential objects. And yeah, here you can see a unique ID is populated for it. So now we have marked that the player game object should be saved. So next we have to decide what all components of the player object we should save. Okay, so player object has lots of components, but the only components that we need to save are Pokemon Party and few data in the player controller, right? So first, let's look at how to save the position of the player. Saving the Pokemon Party will be a bit more complex. So I'll save the player's position from the player controller script. So let me open the script. So inside the script, in order to make this savable, we have to implement the savable interface. So I'll make the player controller implement the savable interface. So once I do that, I am getting an error, and this error says player controller does not implement capture state and restore state functions. Okay, so if you go inside savable interface, it has a capture state and restore state function. So these are the functions used to save and load the data, and this must be implemented inside the player controller. So I'll use control dot and I'll select implement interface to automatically implement it. And now if we look here, you can see both these functions are created. So capture state function is used to save data, and the restore state function is used to restore the data while the game is loaded. Okay, so in the capture state, you can see we have a return type, and the return type is object. So from this function, we have to return the data that must be saved. Okay, and in the restore function, we are getting the object as a parameter, right? So we should use this object and restore it in the player controller. So in our case, position is the thing that we want to save. So in the capture state, we just have to return the position of the player, right? We can just return transform.position. But there is a problem with this. The position is actually a vector3 class, right? So while using a saving system, we can only use classes that are serializable. Okay, only then the saving system will know how to convert that class into binary. So what do you mean by a serializable class? So if we look at our Pokemon class, it has something called system.serializable on top of it. So this attribute makes this class serializable. So such a class can be saved. But a class like vector3 is defined by Unity and it's not serializable by default. So we can't simply return the position like this. So we have to convert this vector3 into some other form which we can save. So how can we do that? So let's think about what a vector3 is. So vector3 is just three float values, right? Three float values x, y, and z. So we can easily represent it by using a float array. So let me create a float array. I'll call this position. And the first value of this array will be transform.position.x. And the second value will be transform.position.y. Okay. You can also store the z value if you want, but since this is a 2D game, the z value doesn't matter. Alright, so we turn the position into a float array and let's return that. So that's how we should do it. So if you don't know what an object is in C Sharp, then you might be wondering why I'm returning a float array even though the return type is an object. So the reason is object is a type in C Sharp that can be used to represent any other type. Okay, so here I'm returning a float array, but I don't have any error because object can be used to represent a float array. Now, if I just return something like a Boolean value, still I don't have any error. So yeah, it can be used to represent any type, including classes. So in our case, we want to return a float array. So through this method, we are telling the saving system that we want to save the position. So next, inside the restore function, we have to restore the position of the player using the object passed in the parameter. All right. So what I'll do is I'll convert the state object into a float array, and I'll store this in an array called position, and then we need to restore the position of the player, right? So I'll say transform.position, and to restore it, the float array should be converted into a vector 3. So I'll say transform.position equal to new vector 3 of position of 0, comma position of 1, right? So now we have specified how the position should be saved and restored. So to test this, we have to save and load the game when some buttons are pressed. Alright, so I'll do that from my game controller. And let's say I want to save the game when the S key is pressed and then load it when the L key is pressed. Alright, so inside the update function, if the S key is pressed, we want to save the game. So for that, we have to call saving system dot I. I actually stands for the instance. So the script uses a singleton pattern. So yeah, we have to use saving system dot I dot save. Okay. And to this function, we have to pass the name of the file in which the data should be stored. So I'll pass some name like save slot1. All right. So next, let's load the game when L key is pressed. So for that, I'll call saving system dot I dot load. Okay. So I'll pass the same file name since we have to load from that file. So this will just be temporary. Later we'll create UI for saving and loading. So this is just to test this easily. And I'll actually put this inside the free roam state since the saving should only be possible when the player is in the free roam state, right? I don't want to be able to save while a battle is going on. So let's go to Unity. And before we test this, the saving system script that we used should be attached to any one of the object in the scene. Okay, so I'll attach it to the game controller itself. All right, so now let's try to test the game. So if I move the player to some other position and if I press S, S will also move the player down since WASD can also be used to control the player. But anyway, for now, let's use it for saving also. So when you press S here, you will be able to see this message. So it says saving to and the path to which we saved. So if you actually go to this path, you can see a file called save slot1. All right. So now if I move to somewhere else and then press L, you can see that the player goes back to the position in which we saved it. All right. So that's happening because we are restoring the position in this restore state function. Okay. So now even if I stop the game and then if I play it again and if I press L, the player will still be loaded to the position to which we saved. All right. So we successfully saved and loaded the position of the player. So now let's try to save data of some other game object. So if we look at an object like the NPC, so let me just open the hometown scene. And if you look at an object like NPC, it doesn't have any state that needs to be saved, right? You can save the position of the NPC if you want, but that's not a relevant data to the game. So I'm not going to save it. And next, let's look at an object like trainer. Let me just enable it and move it somewhere over here. So for trainer, do we have any state that needs to be saved? So we should save whether the trainer is already defeated, right? Once the player defeats the trainer should not challenge the player again. So that state should be saved. So let's go ahead and do that just like we did for the position of the player. So first we have to add the savable entity script to the trainer and mark it as savable object. So before adding it, let me actually turn the trainer into a prefab so that I won't have to add it to all the different trainer objects in the scene. So inside my game folder, I'll create a new folder called characters and I'll turn the trainer into a prefab, and even the NPC can also be turned into a prefab. So yeah, let's go ahead and edit the trainer. So in here, I'm going to add the savable entity script. All right. So inside the prefab, we don't have a unique ID, but in the scene, a unique ID should be populated. So next, we need to save whether the trainer lost the battle or not. So I'll open up the trainer controller script. And in here, this is a variable that represents whether the trainer lost the battle or not. So this is what we need to save. So first, I'll make the trainer controller implement the savable interface. Okay, so let me implement capture and restore state functions. All right, they should be created over here. So in the capture state, what is the thing that we need to save? It's the battle lost boolean, right? So I'll simply return the battle lost boolean from here. And in the restore state, I'll restore the battle lost variable by converting the state into a boolean. All right, so that's all we need to do to save the battle lost state. So using this approach, you can save the states of any objects in the game. All you have to do is implement the savable interface, and then you just have to specify what needs to be saved and restored in these functions. All right, so let's actually test this. So I'll actually disable this NPC and create two trainers. Let me move its position. So yeah, we have two trainers now. And if you look at their unique ID, you can see that both of their unique IDs are different. So the savable entity script will automatically generate new unique IDs when we create a duplicate of a game object. So we don't have to worry about these things. And by the way, let me actually make the trainer weak so that I can easily beat him while testing. So yeah, let's test it. So I did test the game now, but I realized I forgot to do something. So inside the trainer controller script, whenever a trainer loses a battle, we are also disabling its field of view, right? So along with setting battle loss boolean to true, we are also disabling its field of view. Otherwise, it will start the battle again when the player enters the field of view. So inside our restore state, if the battle loss is true, then we have to make sure to disable the field of view while restoring the trainer. Okay, so if battle loss is true, I'll put this line over here to disable the field of view. So you have to note things like these while you restore the states. So let's go to Unity and test this. Okay, so let me go ahead and beat this trainer real quick. All right, so we beat the trainer. So now if we go ahead and save the game by pressing S, the battle loss state of this trainer should also be saved, right? So let's restart the game and test that. So I'll press L to load the last saved state. And now if I go in front of this trainer, he won't challenge me for a battle. And if we go speak to him, you can see that he's saying the dialogue after battle. So the battle loss state was saved successfully. So we didn't defeat this trainer yet. So if I go in front of him, he should challenge me for a battle. So yeah, that works perfectly. So the state of the trainer is being saved and restored correctly. So I'll stop the video here. In the next video, we'll look into how we can save more complex data like the party of the player. So before you leave, make sure to leave a like on the video and consider subscribing to my channel. That'll really help me out. So I'll see you in the next video.